Hi, today we are looking at section 5.3, which is probability using counting methods. So essentially, we will be utilizing information that we learned in chapter 4, where we looked at permutations and combinations, and we'll utilize those to help us solve probability questions. Okay, so first example, 4 friends are competing in a race of 12 people. What is the probability as a percent that they finish 1 to 4? And what are the odds of this occurring? Now, part A, we can actually solve with both combinatorics or permutations. So I will show how to do it each way. Okay, so if we're doing combinatorics, in which case we're not worried about which place they finish, as long as they finish 1 through 4, then essentially 4C4 would be the exact amount of ways we can have those 4 people chosen. So that's just going to be 1. So that's our ways to get what we want. Now that's out of our total amount of ways to choose 4 people, which would be 12C4, which gives us 495. So this is our total amount of ways to choose 4 people. The probability as a percentage A over T times 100, adding a percentage sign. So our amount of ways would be 1 over 495 times 100%. And if we calculate that, that gives us 0.2% as our probability. Then a race of 12 people, the friends finish 1 to 4. Now, if we had done it with permutations instead, essentially, we want to have those 4 selected in the top 4. Now, order that they finish will matter. So that's going to give us 24 different ways they can finish in the top 4. Meanwhile, 12P4 is going to be the total amount of ways of finishing 1 to 4. So in this one as a percentage, we do the same thing. So A over T times 100%. So we've got 24 over 1,180 times 100 add a percentage sign, and we'll find that we actually get the exact same answer. So we could solve part A with permutations or combinatorics. So part B, what are the odds of it occurring? Well, we have one successful attempt out of 495 out of 495 attempts total. So therefore, we have one successful, and if we had 495 attempts minus our one successful, we'd have 494 unsuccessful attempts. We'll look at another example. This one, we'll look at an example where we have some objects are repeating. So for letters used to spell statistics are in letter tiles in a bag, what is the probability that the exact order that you pull them out of a bag will spell statistics? So if we look back at chapter 4 about how to find the different permutations when we've got repeating objects, we take our total amount of objects, which in this case is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've got 10 factorial divided by the amount of any repeating one. So for example, for S, we've got 3 S's. So we'd have over 3 factorial. Then T's, we have 3 T's. And then we have 2 I's. And that gives us 50,400 ways we could potentially arrange tiles as they come out. Now, if there's only one possible way to actually get them to spell statistics, so we will only have one successful attempt. Meanwhile, the rest of our attempts would be unsuccessful, but we have a total of 50,400 attempts. So our P is equal to our attempts over our successful over our total attempts. So our P is equal to 1 over 50,400.